Hello Year 11 and welcome to our third video here on trigonometry. We looked at bearings and angles of elevation and depression previously. Today we're going to look at three-dimensional trigonometry. Three-dimensional trigonometry, these are often, other than the conceptual things, fairly straightforward, I guess. We will be using Pythagoras as much as we'll be using trigonometry probably. The most important thing again are our diagrams. So, recognizing where the right angle triangles are in these diagrams is probably the key, because we're good at dealing with right angle triangles. We've just got to find them. We need to draw nice clear diagrams of them, and typically we'll have a couple of steps. We'll find one dimension to help us find another. Here's an example. There's a diagram. I have a rectangular prism and I want to find the size of the angle ABC. So that's been labelled here, this one here. Now to find the size of an angle, we'll use trigonometry and we need two sides of a triangle. I have at the moment one side of this triangle here. There's a right angle in there. The angle ACB is a right angle. Okay, that's a right angle in there, even though it doesn't appear it on this two-dimensional drawing. There's a right angle in there. The side AC, or that edge AC, is 7 centimeters long, but CB I don't know. Now if I draw a diagram from above, a plan view, here's part of it. I see C and B, and I have two sides of this right angle triangle. So there's this sort of triangle in here. I have two sides of that right angle triangle, 3 and 4, so I can find the third using Pythagoras' theorem. We'll recognize very quickly, 3 squared plus 4 squared equals 5 squared. So now we have BC equals 5, this line here is a 5, and I need a new diagram. So now I have ACB. There's the angle that I'm trying to find, and I know two sides of the triangle, the 7 and the 5. From that, tan is the opposite over the adjacent, and I have the opposite and adjacent, so we're going to use the tan ratio here, and theta will be the inverse tan of 7 over 5, which is about 54 degrees. That's it. So a couple of diagrams viewed perhaps from different angles, from above or from the side, and often we'll find one side to provide some information, to provide another dimension on the triangle that will finally solve the problem. Okay, that's it for three-dimensional trig. There's nothing particularly new, just draw a good diagram. Okay, if you've got any questions, you know what to do. See me in class. I'll see you then.